Glass cleaner can be your friend or it can be your enemy. As you can see here, professional glass cleaner coats glass surfaces with an invisible protective barrier. Some of those blue off-the-shelf consumer grade glass cleaners have silicone inside of that. And what is silicone to adhesion? It's the opposite of adhesion. Same with WD-40, the spray silicone, spray lubricants that your maintenance people might have to stop a squeaky bearing. All of these particles can atomize, make long distances throughout your facility, and compromise adhesion. So be careful when you are spot cleaning or hand cleaning a remaked piece of glass that you're using a proper glass cleaning material. I like to use 50-50 isopropyl alcohol and distilled water. So now we're going to clean a piece of glass. So take your 50-50 alcohol and just basically dribble a little bit onto the glass. Get your lint-free wipes. Okay, and try and clean that glass surface as well as you possibly can, okay? Now, what I think, okay, so you want to be careful as you're cleaning this glass. If you're cleaning the glass with one wipe, what are you doing with your other hand? And I use this small piece of glass on purpose because what happens is it likely will scooch on the table. So what you're doing is you're holding down on that piece of glass with your glove. And a few slides ago, I mentioned if this glove is contaminated, you're pressing down on the glass and there's going to be a printing press effect. There's going to be a residual contamination that you're putting on that glass. So what you want to do in your spot cleaning is you want to have two different wipes. You want to hold down with the fresh wipe and rub with the other wipe. And then do the same thing. Hold down on this side and rub with this side. So you never want to touch the glass surfaces that are ultimately going to be part of the bond perimeter for your spacer system, and as well for visual quality issues, okay? So now that you've cleaned your glass, do you guys have clean glass?
Yes.
Okay, so now I would like you to take a piece of tape, you could see in that picture, take a piece of just regular clear 2-inch packing tape and run it from end to end, top to bottom, and press it down as much as you can, okay? And then right after that, I need you to take your bottle of glass cleaner, which you should have there, and just spray a little bit of that on the glass, and then take your wipes and clean that off. Again, just do the same thing, but instead of using the alcohol and the water. I don't know if you can hear that on your end, but it's squeaky. Squeaky clean, as they say. I guess that means that it's clean, right? If it's squeaky clean. So now take your second piece of tape and put it right parallel with the first one you laid down. Okay. I'm going to pick this piece of glass up and I'm going to look at it. It looks really clean. Now what I want you to do is take the first piece of tape, and you should have a little tail sticking off of the end, and pull up on it as perpendicular to the glass and with even pressure. So if you can hear that, I'm getting a stick slip condition out of the tape. I've got pretty good adhesion trying to remove this piece of tape from the glass. I've actually on my piece got a little bits of glue or adhesive residual on the glass. That's pretty good adhesion. So then, now that you have a feel for what it could be or should be, now take the other piece of tape and it might peel right off.
It did.
Very interesting. So what are we learning from this here? The glass looks clean. If it looks clean, maybe it's clean. There was an invisible sheen or an invisible barrier to adhesion on that glass caused by the glass cleaner, simply by the glass cleaner. So you really want to be careful that you don't introduce something inadvertently that's going to cause a lack of adhesion for your sealant or your spacer, okay? That's the instant death of an IG unit, is when there is a barrier between the sealant or the spacer system and the glass. It's just it. So pretty interesting, huh? Now, there's another factor that goes into what promotes good adhesion for glass, and that is what we call TDS. If you don't know what TDS is, it is total dissolved solids. And I would maybe, if you're still, okay, that sounds complicated. You've all heard of hard water and soft water. So hard water has minerals, a lot of minerals in it, maybe calcium. Maybe you've seen hard water, the effects of it in your kitchen faucet. It makes a white scale. So different locations, even in the same facility, can have different TDS. So you really want to make sure that your TDS is, the glass manufacturers and Bill recommends that you stay below 20 parts per million in TDS, okay, for your final rinse in your wash. So just before the IG gets sandwiched up, you want to make sure that we are, like I said, below 20 parts per million. So how do you quantify that? So what I'm going to do is, our next experiment is, we have a little cup, maybe any type of cup, and take some distilled water. I have purified water, and it says with minerals added for taste. So those minerals are possibly going to affect the TDS. So you don't really want to even use bottled water. But for this demonstration, so I'm gonna fill the cup about half full. I'm going to turn on my TDS meter, okay, and it reads 0. So you guys can follow along here. And there are two little metal prongs that stick out of this thing. And basically what they're doing is they're measuring the conductivity of the water. So you see that chart there, it's specific conductance in micromoles, so, or resistance in ohms. So 179 parts per million is going to be 2,800 ohms of resistance. So let me put the TDS meter in here. And I'm measuring 30 parts per million out of the particular water that I have. What are you measuring over there on your end?
1.
1.
0, 0, 1.
0, 1. So you must be using distilled water instead of bottled water.
We are using purified drinking water.
So there you go. Yours
purified by reverse osmosis.
Reverse osmosis. That's a whole discussion that we can have at a different time. But a lot of the glass washers and facilities, if you want low TDS water, you're going to use RO or reverse osmosis and or deionized water in your glass washing process. So now that you have, say, 0 or 1 or a very low TDS, I rated the kitchenette area here, and I have a packet of sugar. So get out a packet of sugar and pour a bit, maybe a quarter of that pack, into the water and stir it up. So as I mentioned, TDS is total dissolved solids, and I'm going to try and stir this up and try to get this sugar to go into solution and dissolve this sugar into the water. It's going to be hard to do because the water is room temperature. It's not hot, but those sugar crystals are just about gone in mine. So, Okay. Put my stir down. I'm going to get out my TDS meter again. And why don't you guys?
It tastes really good, Bill.
Would you expect the TDS to go up or down from where you were?
Well, we're putting more stuff in there, so it must go up, huh?
It must go up. So, okay. Well, let's prove or disprove that. So put your TDS meter in. What are you getting?
We're only 2, but we didn't put a lot of sugar in. Let's put a little more in.
A little more sugar in. If you think that that's going to help you along, sure.
Blowing my stirring technique. I'm going like crazy on it. Well, there's still a little bit in there. I got most of it. All right.
Well, we got it up to 3.
Okay. I might have thought you got a lot more. Interesting.
Well,
Arguably, it didn't change, or it didn't change appreciably, right?
appreciably.
But it changed, maybe a little bit. Okay, so now take a packet of salt, just regular table salt. You don't need these little packets. You can use your stuff from your kitchen table. Now take about half of that pack. Sprinkle that in, and then again, stir it up. So would you expect the TDS to increase, decrease, or stay the same, or go up at the same amount? What do you guys think is going to happen?
It's got to go up. We're
Yeah.
putting more stuff in there.
Yeah, there's more
We'll
stuff.
put
in
more
there.
stuff in, so it's going to go up. So now if you're happy with how well you've stirred it. Okay, so I'm sitting at 1,200 parts per million. So why did the sugar, so when I put the sugar in my cup, I started at about 30 and I ended up about 30. I was about 30 to 32. It just fluctuates a little bit. But when I put the salt in, it changed to 1,200.
Yeah.
So what's happening is since
Yeah.
the sugar and the salt behave very differently when put into water. They both go into solution, but sugar dissolves into solution and salt dissociates into solution, into a positive and negative ion. So now I've got hard water, or I've got these minerals, let's say, suspended in the water. And now when the water evaporates off, say there's a droplet of moisture or water on the edge of the glass or in the middle of the piece of glass, that droplet is eventually going to dry and it's going to leave a salt stain behind. And that's going to do one of two things. It's going to make a visual quality issue if it's in the middle of the viewing area, or if it's hidden into the spacer line around the perimeter of the IG, that's going to be another impediment to adhesion. It's going to be a layer, like a laminate between the adhesive or the sealant and the glass. And you're going to get no adhesion, and you're going to get a window failure eventually. I hope this was valuable, helpful, informative, and I thank you much for your time.